Assalamualaikum warahmatullahi wabarakatuh and good morning students. Happy holiday and happy stay at your hometown, but please do not forget our lecture today. So today we will proceed subtopic 5.4, which is energy stored in an inductor. Very simple subtopic. So in this subtopic, students should be able to derive and use formula for energy stored in an inductor. So we need to derive the energy first. As we have learned before this, power is equal to voltage or potential difference times current. So power equal to IV or VI. In this topic, voltage or potential difference is referred to back EMF. Therefore, we can write I back EMF. Then, we know that back EMF in coil due to self-inductance is negative L di over dt. Therefore, we can write by ignoring the negative sign. We only consider the magnitude of back EMF. So we just substitute. So power equal to I L di over dt. This is the first equation. Okay. Then we know that power can be related to energy divided by time. So from first semester, we know that power equal to energy divided by time. To inform you all, in this semester, we try to use capital U to describe about energy. Okay, we will use U. This is because capital E is used for electric field. So to avoid confusing, so we use capital U. So we write U over T. Okay. But to derive formula for energy stored in inductor, we consider that P equal to du over dt. Then we substitute the power. So we have one equation. Power equal to I back EMF and power equal to U over T. So du over dt equal to I L di over dt. Then we can cancel dt for both sides. So we will get du equal to I L di. Next, to cancel d in front of u and I, we need to use integration for both sides. So we need to use the integration du equal to integrate IL di. We solve 1 by 1. So here become integrate u, we'll get u, and this one d is for the I, so take out L, so integrate I di. Then u equal to L, integrate I di, we will get I square over 2. Okay. And finally, we simplify the equation. So then the total energy stored in the inductor equal to 1 over 2 Li square. Alright, so hopefully clear how to derive from power to energy. So now we'll look at example. Okay, before that this is the overall the derivation from P equal to I V or I back EMF. Then finally we get U equal to 1 over 2 G squared. Alright, a solenoid of length 25 centimeter with an air core. So length 25 centimeter with a core consists of 100 turns and diameter 2.7 centimeter. Right, question 20A, determine the self-inductance. So as we know that self-inductance equal to mu naught mu r L to area divided by L. We have learned before this, so we just substitute. Mu naught is given, which is 4 pi times 10 negative 7. Mu r equal to, yes, correct, 1 because of due to a core. N square, n number of turns is given, which is 100 turns. In the area is pi r square. So r is not given, but you have diameter, so diameter equal to 2.7, and we divide by 2, we will get r. So 2.7 divided by 2, we will get 1.35 centimeter. Then don't forget convert to meter. Don't forget square. Alright, then divide by length. Length is given 25 times 10 negative 2. So centimeter convert to meter. So just calculate using calculator. So we will get the answer is 2.88 times 10 negative 5 Henry. Alright. 20B. The question asks energy store. If the current flow in it is 1.6, so given I 1.6 ampere. So we know that U equal to 1 over 2 Li square. So 1 over 2 self-inductance 2.88 times 10 negative 5, and then I is given 1.6 square. So final answer 3.69 times 10 negative 5 joule. So this question direct to the point, just substitute the values and calculate, then we got the answer. Right, so we proceed example 21. Okay, look at the question, take out all the information. The energy stored in inductor is 30 millijoules, so energy is given. And then when current flowing through it 50, so current is given. The first question asks for self-inductance. So we have U 30 millijoule, and then we have current 50 milliampere. So for the self-inductance, we have the formula mu naught mu r n square area divided by length. This formula I think not suitable because we don't have any info about length and etc. So maybe we can use energy equal to half Li square. Okay, from here we can calculate self-inductance because U is given and I also is given. So just substitute 30 millijoule. So don't forget convert to joule equal to 1 over 2 L times 50 times 10 negative 3 square. So L should be 24 Henry. Okay. Then the question asks about current, and the question informed that the energy stored increases to 4 times the original energy. So the questions mentioned that U equal to 4 times original energy, which is original energy refer to 30 times 10 negative 3. So 4 times 30 times 10 negative 3. So just use the same formula, U equal to half Li square, and U just substitute the new one, 4 times 30 times negative 3 equal to 1 over 2. L is given 24 and I square. So I should be 0.1 ampere. Alright. So now look at example 22, the last example. As usual, read the question and take out all the information from the question. So given 100 turns, cross-sectional area, and then given B, given time. The question asks the magnetic flux linkage. So the magnetic flux linkage, which is equal to abang, phi, capital Phi, equal to n bar cos theta. So phi besar, abang, n 100, B 0.4, area 8 times 10 negative 4, please change to meter square, and then cos the theta equal to 0. Why 0? Again, we know that the magnetic flux passing through the solenoid always maximum. Cos 0 equal to 1. 1 is the maximum value. So we just calculate, so we get 0.032 Weber. Okay, next question B. The question asks for induced EMF. So just now we have calculated the abang. The answer is 0.032 Weber. So we can calculate induced EMF using the abang. So EMF equal to negative d abang over dt. So EMF equal to negative 0.032 divided by dt. dt change in time. So given that the time is 0.05. So we will get the back EMF negative 0.64 volt. This is the answer. Okay, now, and the last one is to determine energy produced if the resistance is 100 ohm. So given R equal to 100 ohm, here there given R, so we can use the formula energy equal to PT, and power is can be VI or I square R or V2 divided by R. So replace P by V square over R. P V square over R and time T. Why we choose V square over R? Because we have the information. Okay, then substitute the values. So U equal to V just now we get 0.64. We just consider the magnitude. V square over R is 100 ohm and T is 0.05. So U is 2.05 times 10 power negative 4 joule. Alright, okay. So finish example 22. Okay, that's all for today. Thank you so much for your time. Please do the exercises to increase your comprehensions and good luck. Thank you.